Yeah. All right. Hi, everyone. So welcome to our workshop as a part of the programming for the SUI liquid staking hackathon. My name is Henry Dong, and I'm part of the APAC DevRel team. So before we get started, the current registration for our hackathon is still open, so you can still sign up to join. And the registration deadline for our hackathon is September 15th. So if you're interested to find more information and also to sign up, you can search on Google for Sway Liquid Staking Hackathon and then click on the first result. And that will take you to the hackathon landing page. And from there, you can find your way to sign up for it. Okay, so for today's workshop, our guest is Costas. And the topic that is going to be, so Costas is going to introduce some very unique and cool cryptography features that are going to be used in modern 3D apps. All right, cool. So Costas, do you want to give like a quick intro of yourself, and then
Yeah.
start the workshop today? Thanks.
Thanks so much, Henry, for the introduction. Hi, everyone. For those who don't know me, I'm Kostas. I'm also one of the co-founders of Mysten Labs, one of the early contributors of SUI, of course, and I'm leading cryptography here. I have a few slides, Henry. At the very beginning, I can explain what I did in my past so people can understand what I'm doing at Mysten Labs and SUI. By the way, I used to code a lot. And in the past, imagine I'm coming from Greece originally, and I moved to the US like 4 or 5 years ago. But I used to actually lead like the Greek contribution to Stack Overflow since 2014. A lot of questions back then. I was typing in Java and everything, and I worked a lot at the very beginning of my career on biometrics. So imagine how you go to the airports, and then it was typically for all of the employees at the airports to ensure that everyone was actually claiming who was at the time where it was like the very beginning of biometrics on the airports. Then I won a few innovation contests back then, but imagine I didn't start from cryptography. And a few years ago, the only way to work in the business as a cryptographer was probably if you were hired by NSA or some big companies. But I did a lot of machine learning. And however, down the road in 2004, if I remember correctly, I started playing with security related projects, originally starting as a protection to machine learning algorithms, and then eventually in 2009 and 10 for the Bitcoin protocol. I implemented a lot of stuff from fast crypto that we're using today in SUI. I also did a lot of zero knowledge proofs. By the way, before that, I used to be at Facebook, and I worked on the first open source prover for Starks. This was called Winterfell, along with my friend Bobin, who is now at Polygon. And I worked a lot on post-quantum cryptography and proof of solvency. Maybe some of you who are in the space, you have heard for some of our attacks on the solvency systems proposed by some of the biggest centralized exchanges. But we also proposed a solution for them. And gradually, I see some adaptation of like using zero knowledge proofs to prove solvency with some privacy. And then I did a lot of stuff. You will see a lot of randomness beacons. You will see how you can do coupons in SUI. I also did blackjack in SUI, and a lot of attacks, right? You will see attacks on signature schemes and everything. And in this session, let me give the other example. In this session, I will transfer all of my knowledge from the 3 blockchains I used to have in the past. Imagine I started in 2016 officially working for a blockchain company. This was the Corda blockchain system. And then I worked at Facebook. I led the crypto team for the Libra project, and typically now I'm building SUI. So something that changed my career was the fact that I was lucky to work with one of the first developers of Satoshi. This guy was Mike Hard. Mike Hard, maybe you have heard him, is the creator of Bitcoin J for the Bitcoin protocol, but he also co-creator of the atomic swaps on the Bitcoin network. And before even that, I started to do actually at the same time some auditing in smart contracts on both Ethereum and after a while Sui, Solana, and some other systems. And I managed to break a couple of algorithms. Some of them are, I mean, if you search for Fire Lotto and Costas, probably you will find some attacks that I found on some early attempts to create a lottery in the blockchain. And I will explain today how you would do it correctly, even in Sui. Before I also do all of the blockchain stuff, you will understand that the work of a cryptographer is not only proposing solutions, but I was also like a white hat hacker, breaking a lot of things, as I said before, about solvency proofs, that I managed to break a few algorithms. But I also had some interesting results on how we can even break some of the signature schemes that are now used in many libraries, including like governmental or banking software, which was the EDDSA signature, and also a lot of smart contract cryptography attacks. So even if now you're building something independently on the blockchain, and you want to have some like extra soft audit on your code, I typically do it even for free now because I'm also learning, and I want to be able to understand what are the vulnerabilities in all of the smart contracts we have today. I want a better ecosystem, of course, so reach me out. Okay, so very quickly, Sui is using fast crypto, right? A lot of people sometimes are asking, do you implement everything from scratch? We are using some of the best and fastest softwares out there. And Fast Crypto is a Rust-based library. And as you know, Sui programming language is Move. However, all of the platform on the backend is actually using Rust, right? So Rust implementation for the platform, but the language to write the smart contracts are running Move. So the VM is Move, validators are running Move, but the software on which they're compiling everything and they communicate between themselves is typically in Rust. The crypto stuff on the validators and the platform itself is typically written in the Rust language, and we're using the fast crypto. Even if you're not working on Sui, you're working on something else, like Solana of the world, Ethereum, Bitcoin, and you want, however, to use some cool algorithms, go and search for fast crypto, because many of the primitives there are not only for Sui. Imagine that we're experimenting with so many algorithms every day, where you can find from VRFs, VTFs, zero knowledge proofs, various accumulators, a lot of comparisons about signatures, hashes, accumulators, everything. And I have a feeling that many researchers down the road are actually taking advantage of what we're doing, obviously for Sui, but they're doing it for their own research. And sometimes because we have some record speeds, even on zero knowledge proof verification, I would say signature verification, they're using it for their own projects. These are written in Rust, but I know a few people at the community. I mentioned the other day that nowadays it's not only Mr. Labs contributing to Sui, and I'm super happy to see that many got, like a few teams actually got fast crypto and they converted into different languages. One of the most complete one is typically in Python, fast crypto in Python. And you will also see some new algorithms as well, and a lot of comparisons. You can even get like the milliseconds that typically it takes to verify a signature, to produce a hash, to do a VRF, and so on. So the benchmarks typically look like this. And if you go to the fast crypto, let me try it actually. So you can see it. If you go to fast crypto GitHub, you will realize that if you scroll down a bit, you will see this, our GitHub for everything. And then down, there is a benchmark session, and there is a report of the benchmark, which is gradually updated on all of the functionality you can typically find in Sui, but also outside Sui, right? Not everything here is supported in Sui, but most of it, like 90, 95% of it is. And when you go somewhere, for example, someone wants to check, hey, when I need to verify a signature, shall I use the DSA? Where, this is a diagram, typically takes like 50 microseconds, or I should do something else. For example, I will do ECDSA, but using the curve that NSA is using. So your iPhone are using on Androids on your secure enclave, which is typically like double the cost. And we do this for all of the schemes that you can see here. So this is it pretty much, like what we have on Fast Crypto. Take a look, and whenever you have any question, I'm all ears. I want to help everyone to use it. And as I said before, outside SUI as well. So cryptography in blockchains is in many things, right? From the wallet and the authentication, smart contract API. What tools do you have to write proper cryptography on a smart contract? Randomness. Previously, this is very important actually, because previously blockchains had this property of being deterministic. So we want our validators to produce the same result. So when you offer randomness for an application, typically you have some issues, because if you enable it without like any protection and being wise and careful, then you can have situations where the validators are producing different results and they don't agree between themselves to form the next block, right? So we focused a lot on randomness. I have a feeling that because of speed, the object design, object-oriented design, and like the extended crypto API, I have a feeling that randomness will be one of the best like advantages of SUI. I would say starting from now and down the road, because you have many options on how to run a lottery, how to create a blackjack, a casino, a total casino on SUI, how you can do like gacha loot boxes, and you will see some interesting stuff around NFTs. You can even randomize NFTs. And the other thing is platform security, right? Maybe you've seen one of my recent posts that like 160-bit addresses might be vulnerable, even if not today, in the near future. And this is why, for example, in SUI, we're using 256 bits. There are some smart contracts that, even in Ethereum, that with 160 bits might be vulnerable in particular situations. I'm not saying that Ethereum and Bitcoin are vulnerable. And the reason is, for example, on Ethereum, they typically have a database remembering all of the smart contracts and probably addresses they've created in the past. So there is no collision. If you find the collision, you know that this happened previously, so you don't have to check again. But you need the database for this. Then you have cryptography on the validator side. And then, like at the bottom line, you have for light clients, for privacy, for compression. A lot of people are using cool cryptography for bridging. And then obviously the L2s, zero knowledge proofs and fraud proofs that we know on the Ethereum world. However, I will also add the two dots at the top, like these balls here. And one of them is related to cool cryptography for applications and cool cryptography to actually find attacks or even protect against attacks. So this is typically what the cryptographer is doing, all of these 12 things. Now, SUI and the difference between Ethereum. I would say Solana and Polygon and some other blockchains, right? All of them. In SUI, we don't only have one single algorithm, and there is a reason for this. So if you go on Ethereum and Bitcoin, you can typically create a key using the second bullet point here. So it's ECDSA with the K1 curve. As you can see, there are two ECDSAs. So Satoshi was smart enough to not use the conventional elliptic curve, like the third bullet point, but he used the second bullet point, which is the Koblitz curve, because back then we didn't know if, for example, NSA is cheating on the parameters. Even if I don't believe so, some people obviously wanted to ensure that the curve is secure enough. But we support all of these things that you can see here. So in practice, let's go one by one and why you should do what. So the default one is typically ED25519. Sometimes you can hear it as EDDSA. And the reason that EDDSA exists is because it is deterministic. You don't need new randomness every single time you're signing. So it's typically protecting devices and wallets that cannot have a secure way of getting randomness like at the second level just because you're running into your mobile phone or your browser, and sometimes we don't trust like all of the source of randomness entropy to our system. It's also fast, and it can also be aggregated, at least batched and aggregated up to a point. ECDSA K1, we enabled it in SUI just because we know there are wallets out there that are compatible with Bitcoin and Ethereum. This elliptic curve has been proven to be secure, like for the last 14 years in practice, since 2009. And then we also support these types of keys. We also support R1, however. Why R1? Some people are saying, okay, we are supporting one ECDSA, why the other curve as well? This is because modern devices typically have these secure enclaves and the library for implementing cryptographic primitives, that they don't support the K1 curve because it was only used in the blockchain in practice, but they support this one. This is the NSA curve, the NIST curve, sorry, and this is what like your iPhone and Android is running internally in the black box chip that you have, and not even Apple can access it, or Google. Which means now, in theory, someone can have, without mnemonics, creating a key that is stored inside the secure enclave, and then even you don't need to know the mnemonics. It's secured internally. Every single time you do biometric login, and then you have access to your account. However, if you lose your device, then you have other problems. But I will explain why SUI is also secure on this one. The other thing is native multi-sig. Native multi-sig means that you can do K out of n in SUI, with n being less than 10. This exists already on Bitcoin. If I remember correctly, it's up to 15. But typically, smart contract based blockchains, like fully smart contracts where you can do everything, like Turing complete, typically don't have multi-sig, and people are using threshold cryptography there. I'm blessed that we managed eventually to enable multi-sig natively, because you see, when you are launching a new protocol and there are many clients who don't have access to all of these algorithms for threshold cryptography, but this enabled to create cold, warm, hot wallets where people can very easily create a structure where there are more than one key signing. While with threshold cryptography, believe me, it's not so easy, especially for EDDSA. It was like a newer algorithm, as I said, faster, but there were not so many protocols to do threshold until the very last years. But even if we are in the very last years, some people felt like they are locked to the providers that are providing the threshold crypto, and the native multi-sig enabled them to do multi-key custody of their keys without having a dependency on a particular company. And then, very recently, you have heard the news that we are going to provide zkLogin, private authentication, and also send to object. These are very important for account abstraction, and I will explain exactly what does this mean. Previously, you only had the public key to log in, or you have to implement a smart contract. In SUI, some of this logic will be natively supported at the authentication level. No smart contract required for all of the zero knowledge proof stuff at the bottom bullet point. So what you can do with multi-sig, I think we've discussed it in the past. SUI is not like a Bitcoin. There is a small difference, and the difference is in the headlines, as you can see. First, each key can have a weight. It's not like all of the votes is one out of, like all of the keys are the same. You can have a key where it's like more powerful than the other keys, but also SUI can support multi-scheme. Multi-scheme means that you can have 2 out of 3, for example, with one of your keys is ECDSA, the other is EDDSA, and the other is ECDSA, the one used in iPhone, right? So if some people are paranoid or they have different devices supporting different algorithms, they can do this in SUI, while it wasn't possible in other blockchains unless you build a smart contract wallet. And as I said, the important keyword here is native. Imagine that if you have weights now, a lot of things are actually possible that weren't possible before. For example, you can do this one, A or B and C, how you can do a structure which is A or B and C, right? So what I would do is I would create an address where the key A has a power of 2, the second key has a power of 1, and the third key has a power of 1. Then the threshold is 2, and I'm creating a system at 2 out of 4, and you always need at least a power of 2 to be able to sign. And what do we say about power of 2? Like a weight of 2. Key A on its own can sign, or B and C together can sign, and they can meet the threshold, and this is how you can do A or B and C. And as you can see here, you can do a lot of very interesting structures without requiring to do custom logic. You just use plain multi-sig. So other things you can find, SUI has support for natively verifying zero-knowledge proofs. And you will hear this story again and again, what other blockchains are doing for zero-knowledge. Some of them are using them to create L2s, like layer 2 solutions. Some others are doing it to have like privacy at the core level, like Zcash and Monero and Helio and some others. And there is always the use of doing computations faster. So it's compression, computational correctness, but also privacy, 3 things. In SUI, you can use them in smart contracts. It's not that SUI is using in the core layer any zero-knowledge proofs, apart from zkLogin that I will explain, like the new authentication system. But people can use zkp.verify inside their smart contracts. And this is very powerful because now you can build a KYC system. I remember a company called Elusive, if I remember correctly, they are running on Solana, some private coins and this kind of things, where they use Growth 16, and it was very easy to port their logic into fast crypto and then eventually SUI. You can even do anything you want about bridging, rollups, and games, because now you can verify such a proof inside your smart contract. So the other thing that you will see is we're offering many SUI is offering many options for randomness. You can do the coin flip. This coin flip can be converted into any casino game: blackjack, poker against the dealer, roulette, baccarat. I mean, all of the games that you can imagine, craps, everything, using just this first bullet point. I will explain how you can convert this to any type of casino game. The other thing is, which is more difficult, how you can convert this into a multiplayer lottery. And I will explain, you will see we're doing a very smart trick where people can, with just coin flip, they can implement in multiple rounds a multiplayer lottery. Then we also support some native verifiable random functions. I will also show you how to use this. And obviously, as any other blockchain, we have support for oracles. And natively, you can even find some examples about DRAND. I have a feeling that if I type very quickly on, because the DRAND one is very interesting. If you go to your DRAND SUI, a moment, GitHub. Okay, so let's see what DRAND is, by the way, because this is the most important stuff here. DRAND is a distributed randomness beacon. So this is typically run by a few servers outside SUI, and I think it's maintained by Protocol Labs, actually. There is an entity where it produces randomness every few seconds, every 30 seconds. And because we have support, as I said before, for all of these crypto algorithms, you can even verify a DRAND beacon very quickly in SUI. So you don't necessarily need the native VRF. It's already there, like BLS is the algorithm typically used. And you can use DRAND even now to run a lottery for every 30 seconds that at the moment the mainnet of DRAND is producing. So going back again to the slides. So these are the cool things you can get. And the crypto API that you will find is we have all of these hash functions. If you want my advice here, every single time you want like a very quick hash function, typically we pick Blake 2. Second option is SHA-2, and the third option is SHA-3 or Keccak. Typically, people use Keccak if they have Ethereum-related applications and they want compatibility with Ethereum. For signature verification, I typically pick DDSA because it's the fastest one, but also ECDSA R1 and K1 can actually be used. And I will say actually K1 is also super fast on verification. So EDDSA or ECDSA K1. If you don't have any other option or you're using mobile enclaves, you can use R1. We have a full elliptic curve API. We're using the ristretto curve. And now what you will see very soon, there will be 8-word mnemonics. If you want, actually, you can even build it by yourself. This is just like recommendations. Imagine you remember the 12 words that you have for your wallets. Typically, you can even convert them into 8, and we managed to do a one-to-one conversion if you're adding some number at the end of the words and you have more words. So instead of 12 words, you can have horse 4, chess 9, luck 7, tomato 8, fish 3, water 3, play 7, tiger 6. And then there are some interesting applications on wallet pre-approvals. Imagine when you're building a DApp, you don't want the pop-up again and again because you have to sign over a particular transaction intent, right? Every single time you're playing, for example, a chess game and you are moving your pieces, you will see a pop-up. Some wallets, like Ethos wallet, if I remember correctly, they're having these pre-approvals. And the reason that this is easier compared to other blockchains is because we're object-based. And what you can do on the wallet is typically create an allow list. And you say, you see something for $5 for this particular object. And for this game, do not bother me. Sign in blindly in the background. So I want very quickly to move my pieces. And I believe that many wallet providers will do this eventually, because if you want to play games, and Sui is very suitable for games due to speed, you have to have some pre-approval functionality. But every single time, the pre-approval should be somehow allow listed which functions are actually feasible at the wallet side. Otherwise, if you don't have an allow list, someone can convince you to sign for something different. And because of that, you have to be very careful to always check what you are pre-approving. And then you will soon see VDFs, verifiable delayed functions. There is a very interesting example on how you can use VDFs. And imagine one example very quickly, just to have something like in the back of your mind. If you want to run a lottery with the closing prices of the stock market or the weather condition in the top 100 cities in the world, what you can do is you can get a hash of whatever the stock market exchange is actually outputting. And this hash, you're not using it directly. You're using some VDF, like a calculation of a few minutes. And then you verify. Nobody can predict in the second decimal digit 100 stocks, right? It's impossible. You would be rich anyway. But if you add this delay as well, so after the closing price, you also need 5 minutes to produce some computation, hash of hash of hash of hash of hash, or some other operations. And you can very quickly verify that you did all of these operations. This is typically called a VDF. And it's useful because now you're getting public data, and you can convert this public data into a lottery beacon. Okay, so something that some people here might be super interested is how we do account abstraction in Sui. This is one of the most hot topics on Ethereum at the moment, but I can explain here what's the different approach in the Sui ecosystem. So as I explained before, in practice, everyone can build, and there is a company called MSafe that they can build custom authentication rules. For example, they have thresholds on multi-sig, they can do transaction limits. This is coming with some restrictions. However, with the third bullet point that you will see now, like send to object, very soon in Sui, you will be able to send funds into an object and not an address. And this opens the door for many things. Why the first one and the third one are linked? It is because if I have an account that is a smart contract wallet, right? And it's an object in practice. And all of the rules for the authentication are based on a particular object rules. If I can send to object, it means that this object can now receive funds. If this object can receive funds, and now you can have custom logic to do transactions, then it means that in practice you are having all of the cool things that other blockchains are offering, because this object is also a receiver of assets, but it can also send assets with custom logic. However, apart from this, as I explained before, we have a native multi-sig. You can even avoid completely this smart contract development if your logic to sign is very basic, like K out of N. The other thing is novel authentication schemes that we explained before. Many times, one of the reasons of account abstraction is we give flexibility with what people are signing over their transactions. Here, we already have the 4 or 5 algorithms that I explained before. zkLogin will be another one. Very soon, you will see private authentication, which means that you will have a zero knowledge over your logic. Crazy, but in practice, instead of having your logic in a smart contract, you can have your logic offline and you only generate a proof. You register your logic in zero knowledge, and this is private authentication. And then every single time you want to sign, you just provide the proof that whatever I registered at the account creation, this logic, these authentication rules have happened, and I'm giving you a proof that this is a valid transaction. This is super cool, right? Imagine there are banks where they don't even want to reveal that they're using multi-sig threshold or what are the transaction limits they have. Now they can hide their authentication with private authentication. This is coming right after zkLogin. Someone can even implement post-quantum signatures. I mean, now that NIST is actually standardizing them, we will very soon, SUI, we will probably see an SIP, like a SUI improvement proposal, with a post-quantum signature algorithm. And as you can see, we're already working on biometrics. And the biometric stuff is something offered by the community, not Mission Labs. We only helped like on clarifying a few things to make it easier to support in SUI. And the other thing is we have pay for gas, like for someone else, and then transaction batching. You already are familiar with programmable transaction. In SUI, if you are a single person, you can batch all of your transactions into one with programmable transactions. So the main difference between Ethereum and SUI here, imagine that Visa even created like a project to use like a paymaster mode. So you can buy, for example, with fiat money, you can buy some subscription, and then someone else is paying for your gas on Ethereum. So I buy with $100 a sponsor in practice. But this is native to SUI. You don't need to implement a smart contract. By default, any transaction in SUI can be two-party signed, which means that the second party is typically the sponsor, and they can only provide gas. We're not allowing at the moment any two-party signed transaction, but if one of the participants is only providing gas, then this is obviously considered a sponsor transaction. So the address owner doesn't care about their gas object anymore. This is native, right, compared to Ethereum, which is super useful. And I will tell you why, because now you don't even need to top up your account for gas. You can just go and use a gas station someone is providing. These are all already implemented from Tsunami, for example, here. This also allows the example that Visa did, where you can pay sponsor in fiat, and then the sponsor pays you for gas. And you can even do ad services and freemium gasless wallets in the future. Imagine you will have wallets where they will tell you, hey, watch a video of 1 minute, or like an advertisement, and then I will sponsor all of your transactions for the next hour. These are some useful applications that wallet developers can actually implement. So I'm going to one of the most important stuff that you want to know, zkLogin. What is zkLogin? zkLogin is a way to log into your account without having a mnemonic, but using your casual login with Facebook, Google, Twitch, Slack, or like a few other providers button. It opens a pop-up if you don't have already a session, and now automatically you have created an account and you can sign transactions. No mnemonics, zero mnemonics here. This will be huge, of course, because typically in the blockchain, we're looking for investors or for like users who are familiar, like the degens of the game, where they're familiar with mnemonics. But imagine how many developers exist out there, right? And how many users are actually on the blockchain space. It's not so many compared to other regular programming language or other social network users. So if you can get the average user from the social network or like people who cannot remember mnemonics, they don't even know what it is, zkLogin can even hide that you have keys, that you have mnemonics, completely hide it. And let me show you how it will look like in practice and some of the features you will have. So literally, it will be something like this at the middle of the screen. Sign in with Apple, Facebook, Google, email, or whatever it is. You just need providers of the concept called OpenID. This is like the scheme. And at the moment, I believe these 4 are going to be supported. Adeniji will make the big announcement sometime on September, I guess. Assuming all of the auditors are giving like a feedback that doesn't require any big changes. There are many auditors actually on top of zkLogin. I would say at least 3, 4. So we paid a lot of attention on ensuring that it will work correctly. And this is why you haven't seen yet like all of the final code. And very soon, some of the auditors started reporting already. And very soon, we didn't find any big issue at the moment, at least. And very soon, we hope we're going to offer it. There are some very interesting applications in zkLogin. And I'm giving you like the benefits here. It's a native authenticator. It's not a smart contract one. If you remember, I explained before, we support ECDSA, EDDSA, multi-sig. Now there is another one called zkLogin. So the wallets themselves can implement them without requiring to implement a smart contract. The other thing, it's a non-custodial thing. Why it's not custodial? Because the way we did it is you log in with Google. There is an ephemeral key created in the background. Google doesn't know this ephemeral key, and you register it along with the cookie that you get from Google. And then you hide all of this with zero knowledge proof. This means that Google doesn't know this key. We also have like the wallet is providing some entropy as well. So Google itself is not a custodian. The wallet is not a custodian because they cannot impersonate your login with Google. And you are obviously owning your Google account and access to your wallet, which means that it's a self-custody in practice, right? Automatically, Google and the wallet do not need custodian license to operate. The funds are under your control. And if you are using multi-sig, if you want eventually in the future, you can even have like backup scenarios. The most important stuff is the 3 things at the bottom. Imagine if your address is a hash of your email now. These addresses now are claimable. I can send you money before you even have an account, which is super cool, right? It's like Revolut or Venmo of the real system, because now we don't have public keys, we don't have mnemonics. The only identifier is an email, and we're using these companies to identify that you are an owner of a particular email, or like in the future, it might be a phone provider. We don't have one, but it could be. If they verified the phone, we can probably allow it in the future, and then you can send money to a phone number. At the moment, as I said before, you can do it with user IDs, if you know user IDs of people, or emails. This is also making the wallets to be invisible in the future. I believe there will be some games that they won't need a special wallet to play the game. They can just have an embedded wallet. They will ask you to log in with Google. You don't even realize you're in a Web3 environment, and automatically you have accounts. And this also allows the semi-portability, which means that you can use your login with Google with more than one wallet. You can even do multi-sig. I want zkLogin with Google in Ethos wallet, and with Google with Sui wallet, and with Google with mobile Ethos, or Facebook with Sui wallet, right? Using like a combination of zkLogin and multi-sig, you can have some very, very interesting schemes. So how it works? I don't think I've ever said this slide. Now we're at the final stages, and now you can understand how it typically works. So typically when you log in with Google, what you're getting is this particular thing, like a JSON. And this JSON has like 3 elements that we're interested here. So it's the 3 blue like arrows at the left side. The AUD is the wallet ID. Sub is typically the user ID. We can even have an email here. In this example, I didn't use an email. I used the user ID at Google. And there is a nonce. And the nonce is the only thing that the user is putting when you're logging in with Google. Typically, you don't see it now, but in practice, you are connecting to Google by providing some nonce, some randomness. And this is for Google to be secure against replay attacks. But the trick here is, instead of putting a nonce, we're just putting a temporary SUI key. This is one of the biggest tricks. I mean, it already existed, but I will explain how we married it with zero knowledge. So here, let's assume that you put a zero knowledge, you put a public key, and in practice, you're also putting something else, like you can put logic like expiration time, so you can completely get rid of the expiration time of the JWT, but use epochs as expiration, and you can even have like custom logic. In practice, someone can even get a cookie from Google, log in with Google, by not putting the public key here, but putting a transaction ID here. Right, and one login with Google is enough just to sign one transaction. But to sign multiple transactions in one session, instead of putting the transaction ID, we're just putting an ephemeral SUI key. Because it's ephemeral, every single time you lose your cookie, you just go and re-log in with Google. And that's why you don't need mnemonics. That was the whole trick. And we get this cookie, we put an ephemeral key here, the wallet is adding some entropy, some salt. You don't need to know this is like implementation detail. I'm injecting the temp key as I explained before. And because I don't want the blockchain to see all of these things, I use zero knowledge proof to hide it and only ensure that my address, which is now a function of some user ID, not a function of a public key, has received a correct cookie from Google, Facebook, Twitch, Slack. I'm not showing you the cookie, but I'm telling you with 100% security or based on the cryptographic assumptions that I have someone who owns this address, who has some user ID here, nobody can see it, that provided me a valid cookie. And now, instead of just verifying the signature as we did in the previous, before zkLogin, every blockchain is just verifying a signature, right? Now you're verifying a signature over an ephemeral key, the one that you have in the cookie, plus a proof that you have a valid cookie. So this is zkLogin, and it will be super cool on how people are going to onboard on SUI. So the other thing that you can find, and this is like a proposal from K-Class, one of the best SUI developers outside Mr. I've seen, and I'm super happy we have this like type of like experienced people in the community, is you can use a standard called passkeys. Maybe you've seen it in the news. It's a W3C standard for passwordless authentication in practice, and it's supported by most major browsers, UB, iPhones, Androids, and so on. What did we discuss before? Oh, EDDSA is number 0, ECDSA K1 is number 1, ECDSA R1 is number 2, multi-sig will be number 3, zkLogin might be number 4 or 5, number 6 can be this one. And I have the link at the left bottom where there is also a SUI proposal where people can now use, imagine a wallet where there is no mnemonic. Whenever you press the button send now, what's happening is the login from the iPhone is actually popped up. Then you do the face login and it does the signature in the background and you submit the transaction. And there are two modes, actually. You can even store it on the enclave, inside the enclave, or you can set it between your devices. The first one is like link your account into your device. If you lose it, obviously you lost access to the account. You would need a multi-sig here. The second one is it's not stored in an enclave, or in any case, it's shared between your devices, even if it's stored, which means that in practice, you can buy a new iPhone device and now you can retire your old one and you still have access to your account. So this will be huge because in practice, you can do biometric natively in SUI, at least using the iPhone or Android, even UB or browser support, without requiring mnemonics again. So two ways not to require mnemonics, right? zkLogin, and then you will very soon be able to do passkeys in SUI. All of them natively, no smart contracts. So let's go to randomness. Randomness, what do we have today, right? Today we have the commit guest reveal. What does it mean? I will explain in a different slide, but we have 3 algorithms that are supported in SUI, and you can build casino, P2P games, loot boxes. If someone is building a casino in SUI, reach out to me. The tools that you have, you will realize that are very, very useful, and very quickly you can have a transparent casino. And these are typically some of the best applications in all of the blockchain space. We can even extend this to multiplayer. The other is external oracles. As I explained before, we support DRAND. You can also do supra oracles. And as I said, with VDFs, very soon you will be able to use weather or other public data like the closing prices of the stock market, plus VDF, like some delayed function, to run a big lottery, like a national lottery. And by the end of the year, we're going to have SUI-RAND. So we explained before that DRAND is an external committee providing randomness. Our validators will share a secret between them per epoch, and they will produce randomness per narwhal block, which means that per narwhal block now you can have randomness on your applications. And we're working on this now. It will be a cool, super cool feature. Not many blockchains are offering it. I don't believe many of them are doing it correctly anyway. We managed to break a few random beacons on, not break, but prove that are biased. And SUI, you will need 50, 51% or anything more than like the majority to be able to support secure beacons for your applications. Now, obfuscated NFTs. I don't know if you've seen this, but imagine Amazon book preview, right? You're going to buy a book and then you don't see everything. You only see a few things. Eventually, when you buy it, you see the whole thing, right? You can do this in SUI, and we can solve the problems. I can very easily explain to you how you can do it. These are like some cryptography for applications now. You can discretize your image, and you can only show some of the fields, some of the pixels of your image. This can also be a JSON field, right? A JSON element. Like you have a weapon in a game, and then you only want to reveal some of the properties of this weapon, like this sword that is like strength 3 out of 5, something else, but you cannot see endurance. And endurance can only be provided whenever the owner wants, right? And you can even have like situations where this decryption, it can even happen either because the game studio wants, or because the art creator wants, or because the user, the owner wants. And we have created, and now we're working on some protocols. Again, obfuscated NFT is something you can do now with the primitives that we have, but we're going to create a very easy API that you can use pretty much at the end of this year or early next year. But we want this to happen this year, and in practice, you can even get refunded if the creator is not giving you the full image or the full weapon or the full book or whatever it is, right? Now you can have mystery boxes, and if you combine this with DRAND, there is a way to and SUI VRF, there is a way to have gradual releasing of the information. So you buy something, and every day you will see a few more pixels. And imagine what an NFT marketplace this can create. We're calling this a time capsule feature. So these are obfuscated NFTs, and I have a feeling that the new marketplace, we also want to merge this with kiosk and all of this. That's why we need more time to make it like properly. But we already verified with some cryptographers, reviewers out there, like the best of the world, that our construction is secure. So something that you have to take into account if you want to create a Twitter on SUI, it's very easy, right? You can have each post can be an NFT, and something that is important, under your SUI account, you can create an NFT where it's called like a public key. People can register their public keys, and now using this, I can send you encrypted posts. So you can create a Signal or WhatsApp in SUI today. And then I can explain that we have like Satoshi coin flip and all of this. But before I do anything else, I want to show you about the randomness. This is very important, in my opinion. So what you can use for randomness, as we explained before, just by hashing and some VDF, you can use this an oracle for stock market prices. Mining blocks, you can even get something from the Bitcoin if you can verify it. We also have verification of Ethereum signatures in SUI. So in practice, you can use blocks of Ethereum, the hash of Ethereum to run like a particular type of lottery. You can even do flight landings, anything that is unpredictable in the real world. You can use it with some VDFs as well to run a lottery in SUI. But something that is very interesting is how you can do a correct lottery with two people, like a coin flip, and how you transfer this into blackjack. Imagine that like myself and Henry want to run a lottery, like a coin flip between us. So what we will do is Henry will pick a seed in his head. I don't see it. He will send on Sui the hash of the seed, and then I will try to predict if the seed is like an odd or even number, if the last bit is 0 or 1. Nobody can sit here, right? Because I don't know the seed of Henry, and Henry doesn't know what my prediction will be. So the first transaction is sending the hash of the seed. The second one is, and I'm locking funds here. The second one is I'm predicting the last bit. I'm also locking my funds. Henry locked like $10. I locked $10. And now Henry has to reveal the seed, which means that, oh, now we can see who won the game. And every observer in the network can actually check who the winner is, obviously the verifiers as well, and you can pay the winner. There is a small problem here if you just do this. Henry might deny to reveal their seed if they're losing. Right? And this can happen just because they don't have an incentive to reveal it if they lose a game. So something you can do, that's the last bullet point, something you can do is if you don't reveal it after X blocks, player B wins. So Henry has an incentive to do it. Otherwise, they'll automatically lose the bet, and probably there will be some penalty depending on the implementation. And you can extend this if you want to have a multi-player lottery. You can do it in rounds, like as if you play a playoff game. So if you have 4 players here, player A will play against player B, and player C against player D. The winner will move on, will continue to the next layer, and then the winner A and B will play against the winner C and D, and then eventually we have a winner. Now you convert the previous game without any oracles or any external parties into multiplayer lottery with login rounds. You need login rounds here, but if you are a game studio or if you want to make it like a bit more fancy, you can have this playoff structure. And typically you can even say, hey, if you like the time frame for, because as we explained before, someone might decide not to reveal their seed. What you can do is after 20 minutes, if you don't do it, then we go to the next round. And probably in 1 or 2 hours, you can have a multiplayer lottery, which feels like as a playoff game. So this is how you should do it, right? You have to be very careful. I realized many people are using the object IDs as source of randomness or the clock from the validators. This is wrong, because the object IDs are predictable before you submit the transaction. It's a function of the transaction inputs. You can do it if you want to have like a game solitaire or some games without financial incentives, just for the interesting features that you can get very quickly, object ID plus the clock from validators. But if you want like a real lottery with real money, you should do these types of things, or you can do DRAND as I explained before, or wait until we have SUI VRF, and you can do the SUI VRF afterwards. You will not need any external randomness. But I would say that it's not bad to use external randomness as well. Typically, we don't have any examples that there are any types of attacks. So that's all on my side. Henry, I'm getting back to you for any questions.
All right. Thank you for that great workshop. I think I saw a few questions from the audience. Let's see. The first question that's relevant to zkLogin is,
okay.
And Angelo asked, when is Telegram going to be supported for zkLogin?
That's great, right? So we're looking for the help of the community here. To support the zkLogin, first, Telegram has to have on their OpenID this nonce field here. If they don't have this nonce, we cannot support it. That's why I'm telling you, we're looking now at providers that are compatible with zkLogin. You can just go and log in with Telegram and see, and actually you can even post it on our Telegram. If this is supported from the OpenID at Telegram at the moment. I believe they're not supporting nonce, and that's why we don't have it as in the list. We're going to do other solutions there, but at the moment, the very first version of zkLogin is only supporting OpenID providers that they have these particular nonce allowed to be provided by the user. If it's not, then we cannot use it because you cannot register an ephemeral key. You need the key, right? The zero knowledge proof is not enough. You need to be able to inject something into the Telegrams or Google's JSON structure, which is a cookie.
Cool. Okay, so I guess it can only be supported if the login has like this field, right? So
yes,
currently,
something that we can do. That's a good point. Something that we can do is we can probably go to the OpenID providers, like as Mr. Lab, Sui, or some other like who asked this question, and we can ask them to enable nonce so it's compatible with zkLogin.
Cool. All right. Let's see. I think the other question. So like there was one more question, but it's about like token standard. Someone's Cyber Strategy asks, how is the token standard on Sui compared to Ethereum?
How the token is sent.
Yeah, how's the token standard on Sui? How is it different or similar to like Ethereum?
Okay, I have another slide for this. Give me a moment. Let me find it, by the way. Google Slides. Let me do something else. Oh. Okay, so there are a few differences, and give me a moment to explain. This is not cryptography related, but it's somewhat interesting. Okay, I think I have this. Okay, you can see my screen, right?
Yeah.
Okay, so there is a big difference between Ethereum and Sui, right? In Sui, typically you receive things like even on Ethereum and Sui, actually, you receive things, you have on Ethereum you have a balance, in Sui you have objects. Like your balance is not registered under your Sui account, which means that each address in Sui is receiving the assets as if you were in a tree, and then below you are receiving stuff that they point to your address. In Ethereum, this is not happening, right? Because this is happening inside the smart contract. Typically, you have an ownership map there, and then people are sending stuff, tokens or NFTs or anything in a particular hash map inside the smart contract. No. In Sui, they're literally sent under your address. And that's how we manage to not have like a congestion, because if everyone is using this Ethereum contract, imagine people are trying to write at the same huge hash map of tokens, ERC20, and then there might be congestion and you need to serialize all of the, to order all the transactions. In Sui, you don't need it. In Sui, you can receive tokens, you can send tokens, but because you are not touching anything, any big hash map, you can actually have transfers on parallel. This is the main way it works. And in the future, we are also going to have sending Sui assets to Sui assets. This is a send to object that I explained before. So imagine you have an address, and this address will have a bag object, imagine as a basket object, and this basket object will receive funds. And you might have multiple baskets. What's the benefit compared to Ethereum? If your company is acquired by someone else, you don't need to go to all of the Ethereum contracts and find all of your assets and change the owner address, right? Now you transfer this basket to someone else as a whole. So that's the difference on how we're doing token transfer in Sui compared to Ethereum.
Cool.
I can share this slide, right? Plus, imagine sending to an asset, sending to an object will be a cool feature that we're planning to.
Great. All right, I think there's one more question. Casa Di Volvo asks, to avoid bots, do you think the adoption of World ID could be a good a good way to solve it?
Okay, so by the way, to avoid bots, we already did some work. Do you remember that I explained before we can verify signatures inside Sui? I'm going to open source it now because, okay, you're giving me like a great pass here. I'm going to open source a protocol where you can have on your web to a CAPTCHA. And this CAPTCHA is going to provide the signature that you passed your CAPTCHA, and then you can provide this as an input to your function. And we know that someone in Web 2 passed the CAPTCHA before they submit the transaction. That's one way to do it. The other thing you can do it is with zkLogin. You can ask hey, I want you to log in with a particular account. People typically cannot see your email address because we explained with zero knowledge proofs you cannot do it. But the way we construct the functions is we will allow in particular smart contracts, if you want, you reveal that you are at mistonlabs.com. You are a user there. You are not like a random user on any address. And actually, now it seems that if this is a request, I don't know where you're working at the moment, please reach out to me because I have many good ways to actually perform this. You can do it in SUI today, especially when zkLogin will be there. But as I said before, we can have CAPTCHA, we can have zkLogin being used for bot detection, for KYC. Not WorldCoin yet, because we have to check how this applies to SUI as well. But you can also do other stuff. For example, for bot prevention, in your logic, when you're creating a smart contract that wants to have bot prevention itself, you can have a time limits for how many times someone can run your transaction, or you can even do a social graph. If some account is linked to some other account, don't allow more than a connection of 10. All of these are possible, but I promise here that we will publish the CAPTCHA approach very soon. Literally next week. I will try to do next week.
Cool. Yeah, I think that would be really useful because I have also been looking for a way to kind of like implement an on-chain voting system where it would be hard for people to vote more than once. Yeah.
Yeah, it is possible. I will provide all of this example. Actually, I already have the code. Let me create a README file, and you will see if you want your smart contract to have these capabilities, as you said, Henry, you can have it.
Great. Okay, awesome. Okay, I think we have one new question here. It says, Irvin asks, is there a use case for a hardware wallet to allow creation of accounts using different curves? For example, user can create account 0 using ED25529, and then also create one using SEC PK1 as well.
Yeah. Well, as I said before, you can use any of the algorithms that I explained previously. So let me go very quickly on the slide. And this means that typically any wallet can implement any of this. And if you want to also have like a multi-sig between them, you can even do it, right? These are typically just flags. If you say 0, it's EDDSA. If you say 1, it's K1 ECDSA. If you say 2, it's ECDSA R1. It's super easy. Actually, now we have Ledger support, right, for EDDSA, but everyone can implement like a plugin to do ECDSA as well. There is no
Okay.
There is no restrictions.
Okay, so like Irvin is asking for so type of wallet he's asking for is like hierarchical deterministic wallet. Do you know?
Well, hierarchical. Okay, BIP32.
Yeah.
I guess he's referring to BIP32 and BIP39. And we already have these, by the way. Let me show you very quickly. SUI cryptography. BIP39 is already supported in SUI. And give a moment. SUI keys and addresses. If you write down, as explained before, SUI cryptography, you will see this documentation here. SUI wallet. Okay, let me do this. It accepts the specifications, including BIP32 and the variants for SLEEP 0010, BIP44, and BIP39 for all of them. So as you can see, SUI follows SLEEP 0010 for all of the wallets that are EDDSA ED25519. And for ECDSA, we support BIP32. And these are, as you said before, hierarchical deterministic wallets.
Okay, cool.
Right? This is already supported, and I mean, anyone can implement them. And we have all of the logic on how to do it if you want. We have the key derivation path, how you can create like deterministic hierarchical key, and so on for all of the algorithms. Like we say, for DTSA, do this for the path. For ECDSA,
Got it,
NIST
got
curve,
it.
Bitcoin curve, do this. For ECDSA, the iPhone curve, the NIST curve, do this.
I think like Irvin is also asking, is there any case where it makes sense for this type of wallet to switch between the curves, or should they stick to one curve?
So typically the reason that we're picking one or the other is security guarantees and performance. We haven't found any attack on either EDDSA or ECDSA, any of the two ECDSAs that I described before, right? Because as we said, there are two ECDSAs.
Mm-hmm.
In practice, it's like a preference, matter of preference. However, the default one, and most wallets out there are like typically compatible, it's EDDSA. This is because maybe in the future you want to have mnemonic and you want to put your mnemonic out and then you put it on the Ethos wallet or the Sui wallet. Typically, these wallets support deterministic derivation only for EDDSA because they just didn't have the time to do it for ECDSA, right? So if you want higher adoption, just use the first one. If you want to use iPhones or some enclaves to do the key derivation, use this one. If you're familiar with some wallet that was already doing Ethereum stuff or Bitcoin, you can use the second one.
Mm-hmm. Oh, cool. All right, I think that's all the questions that we currently have. So thank you, Costas, for taking time out to do this great workshop, and also to our audience. Thank you guys for joining. And also, if you're interested in joining the hackathon, you can still sign up for it, and just like go to Google and search for Sui liquid staking hackathon. All right, I think we're done for the day, and thank you very much.
Thanks as well, Henry, and
Yeah.
don't hesitate to contact me if you have any questions about cryptography. Anything, even if it's a silly question.
Nice. All right,
Thanks, everyone.
Bye.
Bye.